Salam and welcome everyone. So today we're going to be working on the question on the screen that says the critical constants of ethane are PC equals 48.20 atmospheres, VC equals 148 centimeter cube per mole, and TC equals 305.4 Kelvin. Calculate the van der Waals parameters of the gas and estimate the radius of the molecule. So PC represents what you call the critical pressure. VC represent the critical volume, or you can say the critical molar volume because it's centimeter cube per mole that you're given. And then TC represents the critical temperature. So from this information, we're asked to calculate the van der Waals parameters. So A, okay, that's the van der Waals parameters for attractive forces. And then you have B, van der Waals parameters for excluded volume. And then, of course, we're told to find the radius of the molecule. So that is just simply R. So we're now told to basically, solve it. So the first thing you have to do is this. Whenever you're given a question like this and tell you about van der Waals parameters, well, for you to know that usually the volume unit that we use for van der Waals parameters is decimeter cube. And when we're doing molar volumes of van der Waals parameters, usually, every single time we use decimeter cube per mole. So, and again, we have the atmospheres here and just working with what they call it, the gas constant 0.08206 decimeter cube atmospheres per mole Kelvin. You already know that this centimeter cube is not supposed to be there. So we're going to go from centimeter cube, okay, per mole to decimeter cube per mole. So that's the first thing we have to do. We have to convert. To convert, we have to remember that 10 centimeter is going to give you 1 decimeter. So 10 decimeter cubed, when you cube it to find what 10 decimeter cube is, since we're dealing with volume and not length, we just simply be 10 times 10 times 10. So that's 1000. Centimeter times centimeter times centimeter, that's centimeter cube. And then 1 times 1 times 1, 1 decimeter times decimeter times decimeter. So that'll be 1 decimeter cube. So now we have what the standard conversion formula is. Now we have to use the VC value we have. So we have 148 centimeter cube per mole. So I'm just going to remove the mole because it's not going to be useful in this conversion. So I'm just going to say 148, okay, centimeter cube equals to X. So you just simply cross multiply and then you just have 1000 centimeter cube X equal 1 decimeter cube times 148 centimeter cube. So when you divide both sides by 1000 centimeter cube, you end up with, cancel out the centimeter cube, cancel out the centimeter cube, the 1000, the 1000. And then, of course, you cancel out centimeter cube here, centimeter cube here. So what this is just going to be is 148 times 10 to the power of negative 3 decimeter cube. So X becomes 148 times 10 to the power of negative 3 decimeter cubed. But then let's not forget that we're dealing with a VC question and it's supposed to be per mole. So we're just going to rewrite this to be VC is now actually going to be 148 times 10 to the power of negative 3 decimeter cube per mole. Don't forget the per mole. The only reason why I took away the per mole is just so I can do the conversion, not for anything else except for that. So the next thing you have to know is that they told us what the van der Waals parameters, the critical constants are, and they want us to find the van der Waals parameters. Looking at the physical chemistry Atkins textbook, the 11th edition, you're going to note this, that all of the formulas to be able to find the van der Waals parameters using the critical constants are there. And from the textbook, we have the VC is equal to 3B. So to find what the van der Waals parameters for excluded volume B, we're going to end up with VC divided by 3. So we have the VC, so we're just going to say B is going to be, since it's VC divided by 3, so we have B is going to be 148 times 10 to the power of negative 3 decimeter cube per mole divided by 3. B equals 49.333 times 10 to the power of negative 3 decimeter cubed per mole. So, of course, when you do this, I want to rewrite this in a way where it's easier. So that would just be not just easy. I also want to make sure it's in 3 significant figures because in chemistry, you have to look at the values you use to calculate and see the lowest number of significant figures. And in this case, the main value we were given is just 148 and it's in 3 sig figs. So we have to have our final answer in 3 sig figs. You end up with 0.0493, again, 3 sig figs, decimeter cube per mole. So yeah, that's how it's done. So this is the answer to the van der Waals parameter B. So now we have to find the van der Waals parameter for A. So to do that, we have to remember that there's also a formula to solve this. So looking at the physical chemistry Athens textbook, we see that the formula to find A using our critical values for ethane, we have just critical values formula. It's important for you to know that you have PC, okay, the critical pressure is equal to the van der Waals parameters A divided by 27B squared. We already know the value for B because we just solved for it. We know the value for PC because we were given. So then we can just simply solve for A. So the value for PC we were given is just simply 48.20 atmosphere. So PC is 48.20 atmosphere. So of course we just simply substitute based on what we have. To find what A is, you can just simply cross multiply. Honestly, let's just do it direct. So we have A equals PC 27B squared. So A is just simply PC's what's PC again? PC is 48.20 atmosphere. So we have 48.20 atmospheres times 27 times B squared. So that would be 0.0493 decimeter cube per mole all squared. So when we do this, what you end up with is, I'm going to square this one over here. You have A equals 48.20 atmospheres, okay, times 27 times 0.0493 decimeter cube per mole, all squared is just going to give you 0.0024337 decimeter raised to the power of 6 per mole squared. So decimeter raised to the power of 6 per mole squared. So that is it. So of course you just multiply everything. You end up with A equals 3.16722 atmosphere decimeter raised to the power of 6 per mole squared. Now, I wanted to quickly mention this. Let's not forget, we're going to pick the um, lowest number of sig figs because that's how you work in chemistry. So basically, our answer has to be in 3 sig figs. So the value for A is not just 3.16722. It's going to be A equals 3.17, okay, atmosphere decimeter raised to the power of 6 per mole squared. So this is basically the answer to this question. You have a 3.17 atmosphere decimeter raised to the power of 6 per mole squared. And that's basically the answer. Now, the next thing we have to solve for is just simply R.
So the first thing you have to do when you're trying to determine R is for you to use the equation that is necessary in order for you to determine R for a van der Waals gas. You have the equation from the textbook, which I'm about to write, as B equal to 4 volume of the molecule times Na, where the value for B is what we solve for. So the van der Waals parameters, which we have solved for earlier, 0.0493 decimeter cube per mole, while the volume of the molecule, we're gonna note that the molecule is regarded as a sphere. So a van der Waals molecule, whenever you're dealing with van der Waals gases, just know that the molecule that we're using, we use the volume of a sphere. So the volume of the molecule is just simply going to be the volume of the sphere, since we assume the molecule is a sphere. So that would be 4/3 pi r cubed. And of course, Na is just Avogadro's constant, or Avogadro's number, which is just 6.022 times 10 to the power of 23 per mole. So that's basically what you need. So the value for B, let me rewrite that as B equals 0.09, sorry, 0.0493 dm cube per mole. So when you have all of this information, all you have to do is just simply substitute. So you have B, okay, equals 4 volume of the molecule times Na. When you substitute, you have B equals 4 times the volume of the molecule is just simply 4/3 pi r cube, okay? And then of course you've got Na. So yeah, I want to quickly mention this before we move further. Note that this pi here is just simply the value for pi that we know, which is just 3.1416 or 3.142. I'm going to be using more of the raw data or raw value, so that's 3.1416. So we're just going to rewrite this equation. So that would be B equals to 16/3 pi r cube Na. And next I would be rewriting this equation, okay? So let's rewrite this equation, okay, in terms of r cubed, in order for us to like focus on solving for r itself in terms of r cubed. So rewriting this equation in terms of r cubed, we have r cubed equals 3b. Okay, so 3 times b, because we would have to cross multiply, so that would be 3b equals, sorry, 3b over 16 pi na. So now all we simply have to do is just simply substitute. So r cube is going to be 3 times b. So b is simply 0.0493. But of course, because we're dealing with chemistry, I'm going to want to use the more of the raw value, not just for me to just simply use the approximated value. So I'm going to be using 0.049333. So I'll put that here. So 3 times 0.049 333, and of course let's not forget the unit, decimeter cube per mole. So and then substitute the rest. So you got 16 times pi is 3.1416, and of course Avogadro's constant is 6.022 times 10 to the power of 23 per mole. So of course you cancel out the per mole and mole, and yeah. So next we have 3 times 0.049333 decimeter cube. We're going to multiply the information in the numerator to get 0.147999 decimeter cubed. Okay, divided by 16 times 3.1416 times 6.0222 times 10 to the power of 23. When you multiply the information in the denominator, you end up with 302 0.6994 times 10 to the power of 23. Of course, we would further we're going to further divide this. So 0.147999 decimeter cube divided by 302.6994 times 10 to the power of negative 23 will end up giving you 4.88931 times 10 to the power of negative 27 dm cubed. Of course, because we're told to solve for radius, we have to find the cube roots of this information here. So I'm just going to simply find the cube roots of the left side and the right side. So find the cube roots in order for us to find the radius. So solving for the cube roots, we have r is going to actually be 1.69 726, okay, times 10 raised to the power of negative 9 dm. Of course, because the cube root of dm cube is just going to be dm. And let's not also forget that because we're dealing with a chemistry based question, we have to pick the lowest number of significant figures and put our final answer in that number of significant figures. So looking at this particular part of our question, we see that we have how many significant figures to be the lowest. We see that the value for b, which is the main value that we're given, every other thing, the pi, the Avogadro is constant, every other thing is a constant. So we're just going to focus on b. We know that b is actually in 3 sig figs, even though we use the raw data to determine it. So if you go back to our b value, we know it's in 3 sig figs. That means our final answer here has to be in 3 sig figs. So it's supposed to be stopping at 9. So I'm just going to rewrite the answer to be r, okay, is equal to 1.70 times 10 to the power of negative 9 decimeter. So this is the radius of this question. So hopefully I've been able to like explain it properly. If you're confused, make sure you put in the comment section. I'm going to try to answer any questions you may have, or just rewatch the video. I also wanted to mention that I actually did another question which is very, very similar to this one, and it's going to be on the screen. So make sure you watch that video. It is the exact same type of question, just different values, but still the same material, still the same concept that you're learning. So try to watch that video so that you have like the full picture of this kind of question in your physical chemistry class, in case you're given this in a quiz, an assignment, or an exam. So it's also from the Physical Chemistry Atkins 11th edition. If you have any questions, do not forget to put in the comment section. If you have any suggestions or concerns, I also like to see that in the comment section. If you're a student who wants to succeed in all your STEM related courses, whether you're in middle school, high school, or college, make sure you email me at shahabitutoring@gmail.com. I offer tutoring and mentorship services for students who are trying to succeed as they navigate their academic career. So I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.